Welcome to today's webinar, and we're going to be introducing you to Click2ComputerScience, which is a new website that brings together a lot of different resources that are really focused on out-of-school time computer science programs and how to make them readily accessible to all young people. If you're familiar with Click2Science PD, our first website, you will find elements of the new site that you recognize and that they're familiar from Click2Science PD. But you'll also notice that there are things that are really different about Click2ComputerScience. First of all, it has a lot more resources designed for staff and volunteers to use on their own for their personal development. Whereas on Click2Science, a lot of those resources are designed to be used by a trainer or coach who's helping people build their skills in after school. There's a lot more resources for your own growth and development on Click2ComputerScience. And I want to start today with a video about why computer science is important for all young people, not just the ones that sign up for an hour of code event or a robotics club, but how we can reach everyone with computer science experiences, or why we should. Because just like homework help or physical activity, all young people need computing skills. They're going to be using those in so many different ways in their future. So we want to make sure that they are accessible to everyone. The video I'm sharing today is from Click2ComputerScience. And let me get it started. I just realized that I did not optimize this for sound. Try again.
Computational thinking is one of the best tools that youth can have regardless of the career that they choose, because it's a way to problem solve. A way to look at a problem, break it up into smaller pieces, look for patterns, and look for ways that they can use computational thinking to come about a solution. Increasingly, we're finding that computer science has become a new form of literacy, that kids need to understand just the basics to be literate and doing lots of jobs and lots of opportunities. It's exciting because they love the technology and they want to engage with it, and they're not afraid of it. And so they just want to explore and figure out new things and new ways of doing things, kind of pushing the limits to see what they can do in a program. Computer science is important as we look at the larger STEM fields, because we want to create a STEM ecosystem that happens during school, out of school, summer programs, family nights. Those are all important to create the STEM ecosystem. The question is, what do you want to be when you grow up? Kids often get asked that, and that's a scary, intimidating question. We don't want to tell kids what they have to be when they grow up, but we want to foster a career pathway thinking that lets them consider, if I want to pursue this type of career, what are the kinds of experiences that will help me learn more about it, gain the skills, and help me understand, do I want to go down this or not? So many industry, corporate, and military partners have come to us and said, we have a gap. We don't have enough qualified students and workers in this field, because there's plenty of good jobs and jobs that are innovative and creative. That's what we need these pathways for.
The Computer Science site is really designed for everyone. It's designed for anyone who's teaching computer science and out of school time. That might be staff in your after school program or at a library, volunteers that are coming into your programs, 4-H club leaders, librarians, teen leaders, and college students. And the resources on the site are designed to support building skills in teaching computer science, engaging youth in computer science, and there's also a lot of computer science learning activities that it includes, and resources for program leaders who are planning and running computer science programs, because they do have unique challenges to putting together a computer science program. So you'll see the the navigation up here at the top of the page, the resources for engaging youth, building skills, and teaching computer science are in designing that program overall. And we really hope that all of the people who are working in this field are going to find resources here that can meet their needs. Thank you to everyone who introduced themselves in the chat. You can continue doing that as we have new people joining us. And also, if you have questions or anything you'd like to be sure gets addressed in the webinar today. One of the things we realized as we're putting together the Click2ComputerScience site is that we really want to help people move along two different axes. There's two different types of skills that are really essential in leading CS activities and that we've had a lot of requests for. So one of those is just that knowledge about computer science, understanding what computer science is, and having the basics. And that's what you see along the axis on the left side of the chart. And then there's also a lot of need for experience, especially for people coming in who know about computer science, to build their skills around youth development and working with young people. And that's the continuum along the bottom of the chart here. And our goal is to help people reach that point where they feel like they've got really strong skills, both in the youth development and how to teach young people, and in confidence in working with computer science. So up in that upper right-hand corner is where we think most people want to be operating out of. That's where they're going to be most comfortable. So different people are going to take different paths through the resources on the website in order to reach that level of comfort and feeling confident in both those areas as they're working with young people. So that we have several pathways through the site to help staff and volunteers and others develop and help young people thrive in this area of computational thinking and computing. Today, I'm going to share and highlight some of those resources with you and talk about what computer science and computational thinking are and why we really feel these are essential skills for young people. As Dave mentioned in the video, they're a new form of literacy that everyone needs to have. And you'll see how these objectives mirror that idea behind Click2ComputerScience as we bring together computer science, research, and youth development in helping young people thrive. I do want to take a little bit of time to get to know you and to introduce myself. I'm Dr. Sandra Frarix, and I'm a science education specialist on the Click2Science PD team. And I've helped implement out-of-school computer science programs in Boys and Girls Clubs, in 21st Century After School programs, in 4-H, and in Scouting. And in all these spaces, I really see how much fun and excitement kids bring to this idea of learning computer science through hands-on activities. And so I have a little bit of I'd like to know about you. So in the chat, if you could, how is this working in the programs that you work with? Do you have lots of staff members who are comfortable and ready to lead computer science activities and they just need some resources? Do you have staff that need to build skills in either of those two areas that I talked about earlier in their understanding of computer science or how to teach computer science to young people? What are the needs in your program? I'll pause for a moment so you can share in the chat. I see a lot of people share it in the chat that have the same sort of experience that we've had, that they're looking for resources to help build that confidence among staff, or they're looking for volunteers or experts to bring into their program to enhance that. This is really helpful feedback. I appreciate everyone taking time to kind of share with us where you're at and what you're looking for in your program. The second question I have for you is, what type of computer science or computing activities are you doing in your program? And maybe you're not doing any, but there may be things you're doing that you may not even think about as computer science. There's a lot of software, learning software out there, like Mindstorms Education, programmable robots, VEX, or Lego robots, hardware like Raspberry Pi, Makey. There's lots of resources for teaching coding, apps, and app development. So what are you doing in your programs? I see Arduino, Lego robotics, Python. That takes a little bit more skill than doing the Lego robotics. So you're really building your staff up and building their skills. Hour of code, that's the way a lot of people are stepping into computing programming for the first time. Code Monkey is one I haven't used yet. So as I continue on, I encourage everybody to keep looking through that chat. If you're just getting started with computer science in your program, there's lots of really good ideas about what people are doing and what you might want to do next to introduce computing to the young people you're working with. This is going to be an opportunity today to learn from each other. So I appreciate how willing people are to share their ideas in the chat box. That really improves the quality of the experience for everyone. My objectives for today is we're going to explore this idea of computational thinking and why all youth need to be exposed to computing experiences, how research on teaching computer science can really help us inform how we shape the programs that we're offering in after school. And then I've got some videos to share that will help you see what it looks like in practice and how you can start with some of the simplest activities to get your kids excited. Oh, thank you, Brooke, for your comment in the chat. She's noticed that a lot of people must have their chat set to go to panelists. So I'm seeing all the wonderful ideas that people are sharing, but not everyone else is. So take a moment to make sure that you're sharing your chat with panelists and attendees so that everyone can see what you're sharing. Thanks, Brooke, for pointing that out. So one of the things that I think about when I think about introducing computer science is there was a time not too long ago when the staff I talked to were very intimidated by the idea of doing science in their after school program or doing engineering in their after school program. And they've built some confidence around that. And one of the things that has helped people, I think, are the thinking about the practices of science and engineering, the engineering design process, I feel like has made engineering a lot more accessible to learning in after school programs. So I want to share with you a similar way of thinking about computer science and computing, and that's the practices of computational thinking. Similar to the inquiry process or the engineering design process, computational thinking is a set of practices or processes that you can help young people develop to help them with problem solving. It's a systematic problem solving strategy, and it's a strategy specifically for developing computer-based solutions to problems. A little bit different from the engineering design process, but that same idea of a systematic way of solving problems. And so I'm going to share a video from code.org that introduces the idea of computational thinking. And this is one of my go-to resources. Somebody asked in the chat if there are curriculum around teaching computational thinking. And this is one of those that I would recommend for a curriculum around teaching computational thinking. So let's watch this video that introduces the idea, and then we'll talk about that a little bit more.
The lesson on computational thinking is intended to teach you how to take a big, difficult problem and break it down into several simpler problems. The goal of this lesson is to write a set of instructions that someone can follow to draw one of the monsters included in this lesson plan. Students will break into groups to write instructions, and then they'll switch them with another group that will have to draw the monster. Groups will write instructions using the 4 steps of computational thinking: decomposition, pattern location, abstraction, and algorithms. First, groups will decompose the task, which means make a game plan. Then, they'll look for patterns between all the monsters in the catalog. When they come across differences between the monsters, they'll abstract out or remove those details. For instance, one monster in the catalog has Vegetas eyes, and another has Spritum eyes. But they both have eyes, so we can write a line that says, this monster has blank eyes. So students will be able to write a set of instructions called an algorithm that lists the monster's parts with blanks for what the style should be. This is the set of instructions they'll pass to other students to recreate their very own monster.
So we're going to be looking at the activity that she described a little bit more closely later, but for now, I wanted to talk about some of those vocabulary words that she used that were kind of big, the practices of computational thinking. Decomposition is breaking a problem down into smaller problems, easier to solve that way. Pattern recognition is observing patterns, trends, and regularities in the information that you're dealing with. Abstraction is identifying and extracting the relevant information. The main idea is the important points that are going to help you get to the core of that problem and make it solvable. And an algorithm is the ordered series of instructions that will solve the problem at hand and also solve similar problems. It's like a recipe, the steps that you will go to solve the problem. There's usually more than one way to solve a problem, and a good algorithm should be able to solve more than one problem, but there's not just one way that you can solve that problem. There's lots of different possible solutions. And that's kind of the core of what computational thinking is. And as you think about it in this way, are there ways that you use computational thinking in your everyday life? What do you, do you use any of these problems? So do you use patterns or trends to make your life easier? Share in the chat, how do you use computational thinking practices? I see a lot of people in the chat who like to use decomposition. That's the one I feel like I rely on a lot for breaking things down into smaller parts. Classifying, organizing. It's a great way to manage your clutter, right? You try to use pattern recognition to group things together and use abstraction to remove those things that don't really need to be there. For all of us, digital technology has radically changed the way we work. They've changed industry, finance, services, media, and commerce. And it's really created this need that we have computational thinkers in every field. It isn't something that just applies to people who are going to go into computer science or programming. We're going to be using these practices to solve problems in all areas of life. And there are some places where we can go to in the research to figure out what's the best way to bring computational thinking into out-of-school programs and really make it click with young people so they understand and they can apply these practices in their life. So I want to share with you some 3 big ideas from research that we explore in a little bit more detail at Click2ComputerScience and talk about how these can really make a difference as you're planning how to make your CS programming fit into what you're doing in after school. So 3 findings. First, Researchers found that computational thinking is best developed in a playful context where learners have options and choices. And I love that because it really describes one of the differences between after school or out of school programs and the school day. That there's a lot that a playful context like an after school program has to offer in terms of building these computational thinking practices. Another finding is something I call the use, modify, create progression. And it's a way to structure experiences so that they build computational thinking skills and help learners continue to grow and develop. I'll talk more about what exactly that means and what it looks like. And then the last one is that we need to build low floors and high ceilings when we're creating computer science programs. And that may not make any sense to you right now, but it will before we're done today. I'm going to talk about each of these in a little bit more detail. So this idea of playful context. Researchers advocate that young people who practice computational thinking in a playful way are more successful at really integrating these thinking skills into how they approach problem solving. And this can be through developing their own personal projects, building video games, or building robots, are having opportunities to share and discuss what they're doing with one another. All of these things really help integrate those practices into their thinking. And I love that it fits so well into other things that we're trying to do in out of school time programming. So this idea of giving youth choice and voice, of emphasizing creativity and experimenting. You don't have to get the right answer. You can try something that you're not very good at in after school. All these sort of things really do help create an environment where computational thinking can really thrive. Then the second one was about this use, modify, create. And this approach is out of some research about how to introduce computing and coding in particular in a way that kids learn quickly and are able to keep going. And Scratch is very good at using this model. If you've done any Scratch programming with kids, you're likely to be using the use, modify, create model. You start out by letting the learners interact with an existing computational artifact, a Scratch program that you found online, or a Lego robot build. The one that comes with the kit is an existing computational artifact that they can get started with really quickly. And then they give them the opportunity, the time, and the space to modify that, to start to personalize it, to make it do what they want it to do. And use questions and prompts to encourage their creativity as they're modifying and changing this, to help them get to the point where they understand what they're doing and they can start to create their own projects that are similar to the one that they started out with. So as you're helping them build that confidence, they're gaining the skills to develop and create their own projects. And that's where they're really integrating the computational thinking practices. So you're starting with an existing artifact, a program, an activity, modifying that, and then allowing the time and space for them to develop their confidence in creating their own program or animation or whatever it is they're going to be working on next. This also leads into the idea of low floors and high ceilings. And this is the idea that any activity you're doing in your after school program should be really easy for kids to get started with without a lot of direct instruction, that they can start out on their own with a low floor. It's easy to get started. And it is intuitive enough that they don't need to sit and be taught how to do it before they get into it. They can start out easily, but at the same time, there should be enough kind of behind the scenes so that there's opportunities for new and creative ways to use their skills, to keep developing new things. And that's where the high ceiling is. So you want to start with something that's easy to get started, doesn't require a lot of instruction before they get going, but is flexible enough that they have lots of different ways that they can modify and use that tool to create their own resources. And with these three ideas of creating a playful context, low floors and high ceilings, and that use, modify, create progression of experiences, I want to add in one more element to think about, and that's youth development. And this is one of the ways that I think out of school computer science learning differs from technology or a computing class in school. The focus we have in after school is helping young people develop their full potential, to explore new ideas and to build their identity into what they want to do and can do in the future, and develop life skills along the way. We're not trying to get them to know everything that they need to know about a topic. Instead, we're focusing on that development of the whole child and thinking about their identity, who they are and who they want to be. At Click2Science, we talk about the importance of developing a STEM identity. And that's true in computer science as well. We want to help young people see themselves as someone who learns about, uses, and contributes to computer science, that this is something they can do and they can be a contributor, not just somebody who's using computers, as we all are every day. In computational thinking, we want to help young people see themselves as someone who can use digital technologies to solve problems, so they can envision that future self and identify the series of supporting experiences that can help them get from where they are now to that vision they have for themselves in the future. Learning how to program a robot may help people learn how to use computational thinking, to enjoy having their new skill, and then to realize that they can use this new skill to solve problems, which leads them to seeing and valuing themselves as a computational thinker. When youth are able to see and value that self as a computational thinker, it becomes part of their identity. And having an identity as someone who's good at computer science specifically, or STEM in general, helps young people access a lot of important opportunities in their future. Opportunities in education, in work, or in using technology in their day-to-day living. There's a whole world of possibilities that are open when you can see yourself in that type of future. Great paying careers that are open and available to computational thinkers. So we really want to be intentional about having consistent messaging around computational thinking, that this is something you can do and you can apply this skill in all areas of your life. So I've kind of tried to give you a little bit of background. Now I want to think about, what does this look like in practice, and what are some concrete things we can do right now, some resources that you can take back to your program to really build and grow your your computer science program from where you are now to where you want to be. So in the video that we started out, the computational thinking video, the second video we watched, we introduced this idea of the game without rules. And now we're going to watch a facilitator who is leading you through this activity and trying to help young people see themselves as computational thinkers. As we watch the video, notice how he emphasizes both the learning, what he wants them to understand, and this idea of developing their identity, and how he brings both those things together in working with this group of English language learners. He's created a fun activity that he kind of adds into this that reinforces for the language learners the new vocabulary that they're learning, as well as their identity. And then you'll see them going into the activity that was talked about a little bit earlier, and how they're using those computational thinking practices in that activity.
You're a computational thinker.
You're a computational thinker.
Awesome. To form STEM identity, the youth need to be able to form that opinion of themselves, and they need to internalize it. So how does that happen? So one is awareness. So knowing that these things are out there is definitely helps form identity as a kind of a passive, that thing exists, thus I could pursue it at some time. But to go beyond that, we also have to have some of that identity formed within the students. Once I became a partner with Jay here, I'm going to pick one of those words and I'm going to say decompose, break a problem into smaller pieces. I'm going to say a definition, and then Jay's going to choose one. So just choose any one of those four, and you're going to do it over and over and over. Okay, which one? And what's the definition?
That you can follow to finish a task.
Boom. All right, so we've both said a definition. We're going to say, you are a computational thinker. Say it to me. And then I go find another partner. Right? So then I Today, during this lesson, I happen to have the students orally say, I am, and then whatever that identity is around, and multiple times, in multiple ways, in multiple contexts. So with the success, I wanted them to say, I am the computational thinker. So what do I do first? I need to choose a animal. So this is that algorithm. Okay, so I'm going to choose a puppy. All right, what do I do next?
Roll again.
Oh, okay. And then I write it down. I'm figuring out the pattern here. Yeah.
And you gotta go again.
And again, okay.
That's one.
And
You got
a two.
two. Then you got one, so you're gonna put a cell
Thank you.
phone. Then,
Cell phone,
Then
okay.
you got a two again, so you're gonna put a cell phone, a blue cell phone in his tail.
On the horse's tail, was there an example? Okay, that's what the cell phone needs to look like. Blue cell phone on the puppy's tail. Yeah?
Yeah.
So you just gave me a set of instructions. Do you remember what that word's called? Algorithm. So you gave me an algorithm to solve this problem, right? To follow these instructions. You guys are great computational thinkers. Can you all look at each other and be like, I'm a computational thinker? Like you're fixing your hair? Yeah. So reinforcement of that helps them internalize that as a way for them to begin to solve problems.
Then they blink and then they blink.
Nailed it.
That means
Yeah.
I need to draw a blank on my blank and my blank.
You nailed it. You're a computer scientist. Even if they don't become a computer scientist, being able to be a multifaceted person, be able to have multiple skills, this would remain with them, that they become a problem solver. It's a transferable skill, and having them feel that inside them by saying it, I think is super powerful.
So what did you notice there in the video? What were some things that were supporting the learning or the identity? You can share your ideas in the chat. by having them use that vocabulary over and over, that repetition is helping them really get comfortable with those words. But then the celebration and the affirmation is also supporting that sense of developing identity of who they are and the fact that they are able to do this to build their confidence. This is an example of an unplugged activity, CS Unplugged, and the CS Unplugged activities teach computational thinking, but as you notice, they're not using computers at all. And I realized this is a different game than what we talked about, or different activity than what they talked about in the first video, because that first one was about monsters. We have a video about the computational thinking with monsters activity as well, but here they're playing a little bit different game or activity that they're learning, but still supporting that idea of developing computational thinking skills. So as we look at the next video, I want you to think back to those computational thinking skills: decomposition, pattern recognition, abstraction, and algorithm, and look for examples of how youth are using those as they're doing this activity.
Okay.
What number left?
Yep. The objective of the game without rules is to provide the youth an opportunity to intentionally take all 4 parts of computational thinking and apply them and get to that end goal so they can see it all together as a method. We start with decompose, so we break down the problem. And then we look at any types of patterns. Another step is abstraction, so that's taking out all of those differences and really taking a look at what might be able to be applied in different ways. And then finally, we're looking at creating algorithm. And so we're creating that algorithm, that list of steps to solve that problem. We started with an activity that was very challenging and nearly impossible in a very purposeful way.
So are you ready for a really big challenge? Yeah! All right. So you can't use paper and you can't use pencil for this challenge. You have to just use your brain, all right? Sum all of the numbers between 1 and 200 in your head. You have 30 seconds. Are you ready? Ready? All right. Think about it. Go.
And so the point of doing that is to set up that things are challenging and we need tools in order to solve them. So after the kickoff activity to get them to start seeing this, we started getting into a game that had no rules, with no instructions.
Sometimes when we are on the computer, we don't have instructions and we need to figure out what's going on. That's what we're doing. So the first part, the suggestion is to circle the sections of words that are identical from player to player.
I facilitated kind of a back and forth between the students in order to get them to start seeing that they can break down the problem.
Yeah, so first, let's see if we can find any patterns. So if we read that first sentence, take a look at that first sentence. I choose. Yeah, I choose, I choose. Is there anything else here? What's the same in these 2 sentences? What can I circle just like on your activity?
I have 3 orange cats and I have 2 orange fish.
Awesome. So our next step is underline the words that change from player to player. So out of these sentences, what's different?
2 and 3, fish and cat.
Okay, 2 and 3, and fish and cat. And then third, on this bottom part, you're going to write a script. What would a computer do in order to play this game?
So they completed that game using computational thinking and all 4 areas. At the end of that lesson, they had to write that script, that algorithm, in order to have someone else play the game with them.
We have to choose an animal first.
All right, first step, choose an animal. In my algorithm, that's what would go first, right? Choose an animal. Then what do I do?
And then you roll a dice to know what color. To know what color. And then you roll again, and then you get a 6. You have to get, if you got a 2, you have to get a blue bow.
I'm going to see if I can decompose. I'm going to break it apart. There is a yellow cupcake on a tiger's tail. So that means a 2 is rolled, 4 was rolled and a 3 was rolled. Am I right?
Yeah.
Yeah? Awesome. So I can tell, I can go backwards and forwards based on what you did. You guys are awesome. So at the end of the activity, they had the instructions that didn't exist before.
So now we want to think about where are those practices in this activity. So did you see them using these practices as they went through the activity? They're breaking the problem down, looking for patterns, abstraction, identifying the relevant information. That reminds me of the comment that Zainab made earlier about reading and focusing on the words that are really important, ignoring the junk words. That's what they're doing as part of this activity too, and then ending up with that algorithm. So we're almost out of time. I'm wrapping up today and then really going to go back and look through and try to address some of those questions you have. What I want to leave you with is a simple idea. You can do this. You can do computer science. You've got research behind you informing how you can present and structure experiences in your program to really help youth develop their computational thinking practices, that sense of identity as a person who uses computer science, and then using that playful, use, modify, create progression, you're going to make those activities more accessible to young people and also easier, I think, for your staff to lead and to relax and have fun. It doesn't have to be perfect the first time. You're going to start with something pretty simple and then build on it and grow as the young people that you're working with are growing and developing too. So your staff can be developing their skills at the same time that the kids they're working with are. And the overall goal is to really open up to the young people in our programs this world of possibilities and opportunities that are available for somebody who has the skills in computer science. So, leaving you with some ideas. There's a whole section on the Click2ComputerScience website that will help you think about how to support young people in computer science, how to understand computer science better, and also a whole bunch of computer science activities that you can get started with right away. We're trying to bring together some of those free resources and make them easily accessible to that. And yes, I see the question in the chat about the links, and I will share those with you. And I also want to go back and look at the questions that you had earlier about how to about computer science, but I realize that we are about out of time. So here is the link to the Click2ComputerScience website, and here is the link to the code.org activities, the CS Unplugged activities, 20 hours of lessons that you can use to teach computer science and computational thinking without having any computers at all. And all of these resources will also be posted with the recording on the Click2Science website in just a few days. And let me put the link to there too. This is where you'll be able to find the recording. I am going to stay on and go back and address the questions that you had, but I want to thank everyone for participating today and for being part of our webinar.